Hi, so in this video, we're just going to summarize the three key reciprocal trigonometric derivatives that we proved in previous videos. So let me just make a title of derivatives. So derivatives of reciprocal trig functions. So the reciprocal trig functions, so they're going to be COSEC, SEC, and COT. So if we start with number one, so the first one we did was differentiate the COSEC function. So when we differentiated COSEC, the result we got was this. So we got negative COSEC of x multiplied by COT of x. And just to mention the domain of this COSEC function, so we know by definition that COSEC is just the same as 1 over sine of x. And so this function is not going to be defined when sine of x equals 0. Where does sine of x equal 0? Well, it equals 0 at n pi, where n is an integer. So cosec of x is defined on a domain of all real numbers apart from n pi, where n can be any integer. So n in the integers, like so. Okay, so that's the first one we did. The second derivative we did was the derivative of the sec function. So when we differentiate sec, we prove that the result we get is sec of x multiplied by tan of x. And again, if we just consider the domain of this sec function, so sec is just the same as 1 over cos. Where is the cos function not defined? Well, it's not defined at pi over 2. It's not defined at negative pi over 2. Not defined at 3 pi over 2. Not defined at negative 3 pi over 2. Not defined at 5 pi over 2. And not defined at negative 5 pi over 2, and so on and so on and so on. So x is not defined for 2n minus 1 over 2 times by pi for n in the integers. So all odd numbers divided by 2 times by pi, that's where the sec function is undefined, but it's defined for all other real values of x. Okay, great, that's that one. And then the last reciprocal trigonometric function we found the derivative of was this COT function, and the result we got for this was negative cosec squared of x. So if we just consider the domain of this COT function, well, COT is defined by cos of x divided by sine of x. So this function is clearly not defined when sine of x equals 0, because you're going to get a number divided by 0, which is undefined. And we know that sine of x equals 0 at those points there, so the n pi points. So therefore, we know that our domain for this COT function is just going to be x in the real numbers apart from n pi, where n is any integer. So yep, so that's they're the results that we proved. Just one point about this COT function that I probably didn't make when we actually did this derivative. So COT of x is actually defined as cos of x divided by sine of x. So it's actually not defined as 1 over tan of x, although it is actually indeed equal to 1 over tan of x, but only at certain points. So it's equal to 1 over tan of x only, well, for all points. So for all x values. So for all x values apart from, when, so apart from when cos of x equals 0. So why is that the case? Well then, we know the tan function has, if we just draw a sketch of the tan function. So the tan function has asymptotes between, the asymptotes are at pi over 2, 3 pi over 2, and so on and so on. So what happens then? Well, when we divide 1 by the tan of x function at these positions of the asymptotes of pi over 2 there, 3 pi over 2 there, and so on and so on. The problem we get is that we can't do 1 divided by an undefined value. So therefore, 1 over tan of x is undefined at these points there. However, cos of x actually is. So if we go to a new page then, so if we consider cot of pi over 2, well, cos of pi over 2 is the same as cos of pi over 2 divided by sine of pi over 2. So we know what cos of pi over 2 is, so that's just going to be 0. And sine of pi over 2 is just 1. So this is 0. So cos of pi over 2 is 0. However, 1 over tan, with us inserting the pi over 2 into the tan part, so but 1 over tan of pi over 2, well, that's undefined. So this is undefined because tan pi over 2 is undefined. So in fact, cos of x does equal 1 over tan of x, but only for all x values apart from when cos of x equals 0, because when cos of x equals 0, the tan function has these asymptotes. So yeah, that's something that I didn't mention before, but that's quite a key point to realize. So yeah, so the results of the 3 reciprocal trig functions are as follows: this result there, that result there, and this result there with these 3 domains. So yeah, that's that video done.